Hey everyone, in this video we're going to be going over transition metals in ionic compounds and the system we use to indicate their charges. So remember that transition metals can have a varying number of valence electrons, and so they can take on different charges, and it depends on who they're paired with and where they're coming from and just basically the circumstances. So when we name an ionic compound with a transition metal in it, we have to be very specific about its charge for that situation. I also want to remind you, so if you think about like our stair step here, okay, we're talking about all of these elements. Anything in this purple, well now I guess blue shaded area are the elements we're talking about in this video when I'm talking about transition metals. It's very beautifully artistic. So the system we use to indicate the charges on the elements that live in this purple, blue, scribbly shaded area is using Roman numerals to indicate their charge. So for example, you can have the compound name copper and then a 2, right? Sometimes we see it with the little lines, 2 chloride. So just to remind you, in Roman numerals, we have 1, and then 2 is 2 I's, 3 is 3 I's, 4 is 1 before 5, so that I is 1, and then before 5 would be the V. So that's a 4, and then 5 is just a V. So you won't really see anything going higher than that in these instances. So 1, 2, 3, 4, whoop, 5. Okay, something to think about is that the charge on the Roman numerals is always going to be a positive charge. Because it's always going to be describing the charge on a metal, and metals are always going to be the cation. They're always going to be losing their electrons. Remember, cations are positive. Cats have paws. So let's practice writing some formulas. We're following the same exact rules of writing ionic formulas that we've seen in the previous videos. However, now we are using the Roman numerals to give us some information. So you should hopefully have your labeled periodic table out to be able to do these as we move through the examples. So copper 2 chloride. So copper is Cu. This 2 here indicates that it's a +2, right? It's always a positive charge because it is a cation. Okay, chloride then we find lives in group 7. It's going to have that -1 charge. So the same process as we used before, where we find the ions, their charges, and figure out the ratio they're going to combine in to make sure all the charges even out. So if this copper is +2 and the chlorine is -1, I'm going to need a second chloride ion there to balance out the copper. So a +2 will even out 2 -1s. So then my formula is CuCl2. I need 2 chlorines there to even out the 1 copper. Okay, so same exact rules. I just got this 2 from the name. Let's try another example. Iron 3 nitrate. So iron is Fe. This 3 here tells me that it has a charge of +3. And then nitrate is actually a polyatomic ion. So you want to go look at that polyatomic ion list. That 8 ending gives you a hint. That's where you should look. Okay, and I'm going to go ahead and preemptively put parentheses around that NO3 because I know I'm probably going to need more than one of those. So the iron piece has a charge of +3. Each nitrate piece has a charge of -1. So I'm going to need 3 total nitrates for that to even out, right? That would give me a total charge on the positive side of +3, total charge on the negative side of 1, 2, 3, -3. So that formula then is going to be Fe and 3 nitrates. Remember, we put our polyatomic ions in parentheses when I need to add a subscript. It's not NO33, right? It's NO3 in parentheses with a 3 on the outside to indicate that there are 3 nitrate pieces. So that is iron 3 nitrate. And then our last example, lead 4 oxide. All right, so lead is Pb. This 4 tells me I have a +4 charge. Oxide is referring to oxygen. Oxygen has a -2 charge. All right, so I'm going to think about how many of each of these I need to get to that least common multiple. The least common multiple of 2 and 4 is 4. So that means I'm only going to need 1 lead, and I'm going to need 2 oxygens to even that out, right? That will give me a total of +4 and then a total of -4 if I have 1 lead for every 2 oxygens. So that is lead 4 oxide. Let's go the other way now. So this is a little more challenging because we do actually have to work backwards. So when writing the names of ionic compounds with transition metals in them, you need to pay close attention. First, you need to notice that you have a transition metal. When you notice you have a transition metal, you need to be prepared to figure out what those Roman numerals are to include that in the name. You have to include the Roman numerals to indicate the charge in the name. So we're going to work backwards thinking about this whole idea of the ions combine in these ratios to make sure they're neutral, all the charges are balanced. So we're going to use our information of whoever this transition metal is paired with, the anion it's paired with, to determine what the charge on the metal is. Okay, so here we go. Right, so I'm going to do this in kind of 2 steps. So I'm going to figure out the elements and the ion names, and then go back and figure out the Roman numerals. So Sn is tin. So I know it's tin. Okay, I know because it's in that shady purple area of that periodic table I showed earlier, it's going to need Roman numerals. I'll figure out what those are in a moment. So tin, something, and then chlorine as an ion or in a compound is going to be chloride. All right, so let's work through figuring out what the charge on tin is in this case. So I have tin, and I know I have 4 chlorines. Each chlorine, because it lives in one of those main groups, the tall groups, it always has a charge of -1. So I know the total negative charge is -4, right? 4 chlorines, each of them having a -1 charge, is going to give me a total negative charge of 4. Well, I only have, according to the formula, 1 tin atom to cancel that out. So the charge on that tin atom, I have to reason backwards, it has to cancel out all of the -4. So it has to have a charge of +4. That's when I can write in Roman numerals, tin 4 chloride. Let's try a second example. CuSO4. Cu is copper. I am again going to remember that that's a transition metal, where when I hunted on the periodic table and found Cu representing copper, I used the fact that it's in that shady area. I got to call out its charge. And then SO4 is a polyatomic ion. It is sulfate. So we are going to now have to, again, work backwards and figure out what the charge on copper is in this situation. So I'm going to do that in green over on the right here. So I know sulfate is a polyatomic ion that always has a charge of -2. And according to my formula, I have 1 copper and 1 sulfate. So the total negative charge is -2, and I only have 1 copper to cancel that out. The 1 copper has to cancel out the whole -2, so it has to be +2. Okay, so then since it's +2, I'm going to put that numerical value 2 in Roman numerals in the parentheses. All right, last example I'm going to do in blue here, FeO3. So I know Fe is iron. Again, Got to put its charge in there since it's a transition metal. We'll figure out what it is in a second. O is oxygen. In a compound like this is going to be oxide. So let's figure out what the charge on iron is in this case. I'm going to draw out my compound here. I'm going to separate it out. 2 irons, 3 oxygens. Well, each oxygen has to have a charge of -2. Okay, and I don't know what the charge on iron is. So I know, since each of the oxygens is -2, the total negative charge is -6. So that means the total positive charge has to be +6. Well, +6 separated into 2 equal-sized charges has to be +3. Right? I have 2 irons to get me a total of +6. So each has to be +3. So my name here would be iron 3 oxide. So make sure anytime you see a transition metal, something that is in that shady, let's go back and look at that shady section in the periodic table, you need to add Roman numerals in the name or use the Roman numerals in the name to find the charge and write the formula. All right, thanks for watching, guys.